Hello everyone, my name is Rohit Jafari and I would like to welcome you to another video. In this video, we are going to focus on regression. Regression is a series of statistical methods for estimating relationship between different variables and eventually being able to get some idea or prediction about the future outcomes of the future data objects. So in this video, we're going to look at this setup or this series of methods and learn a little bit about them, what they come from and what do we really do when we do regression. Okay, let's look at this now. Alright, so the agenda on this video is going to be very short. We're going to see sort of what is regression, and then we're going to see the difference between linear and nonlinear regression with a couple of examples. So to first off, sort of understand this method better, let us understand what is the word regress, which regression sort of stems from, right? The meaning of the word regress is to return to a former state. That's what the word regress means. So to understand this better, let me show you this example of Paul George performance in the last 12 games. In these last 12 games, Paul George, who's one of the best three-pointers as a basketball player, he's been able to achieve these performances. Here is this is the last 12 games of Paul George, and this is sort of like the trends of the percentage of success for his three-pointers. So let's imagine we are one day after the third game where Paul George was able to achieve 60%. Right, if we are simple-minded and we don't know about this phenomena of regressing, we might kid ourselves, by not knowing what might come in the future. So let's imagine these are not here. We're just in that day, and we hope that Paul George has magically improved and he's going to perhaps keep his performance, or even better, even increase on this. You sort of like can hopefully see a line here that he's going to improve here. But the reality is that what's going to happen is Paul George is going to regress as he did. He is going to go back to a former state. This is kind of the same thing. It doesn't have to be only when a good performance happens. When sort of like a less performance happens, like day 8, the coach would be, if he's not statistical minded or pessimistic, would say, oh my god, I've lost one of my best players, he's never gonna like play the way I want. Of course, there's gonna be a regress to the former state. So what is this former state here? This former state, if you calculate the average of all of his, you just count all of his shots in these 12 games and see how many he's been able to achieve, you get around 36%, right? So this is sort of like the former state or the baseline for Paul George. So, every time it goes a little bit higher or it goes a little bit lower, you kind of expect Paul George to regress. And that's what regression is. That's what the word regression comes from. So with this, introduction to the word regress, let us talk about what is regression. Regression is a statistical approach to estimate the relationship between independent attributes and the dependent attribute. And that's basically what it is. But there are different types of regression, and we're going to see that in a minute. So if you remember, when we were talking about the task of prediction data mining task, we said it's basically connecting the independent attributes to a dependent attribute. And regression is one of those algorithms or one of those methods that can do that. But we did see that this connecting things will be done by a linear equation, and when we do linear, it will be done by an equation, and when we do a linear regression, our equation is going to be linear, right? So we have beta 0, beta 1, beta 2, beta n for our n number of attributes, but all of these terms, there are linear terms. So we haven't added anything non-linear to this equation. And as far as we keep that, no non-linear term in the equation is going to still remain a linear regression. We move to non-linear regression when we add non-linear terms. So we could sort of like make our equation that we are trying to use as a way to capture this relationship a little bit more complex and add a term like this one, right? So an interaction term between predictor I and j, and this predictor I and j could be anything. Could be predictor 1, could be predictor 10, and this function also could be anything. Like for example, this could be b beta 1 9, and multiplied by predictor 1 power 2 predictor 9. This interaction term could be anything, and this is a very open space for you to come up with any equation that can possibly be suitable for this relationship. And that doesn't have to come with other linear terms. I mean, this is all of the linear terms are here. It can be just those linear or non-linear terms by themselves. That still would be a non-linear regression. So let's look at an example. If you remember in the example that we discussed prediction, we were trying to predict the number of student applications Mississippi State University receives yearly receives this university by looking at the previous year football performance and the average number of applications from the last 2 years. So what we did here, we basically said, okay, this relationship maybe can be captured by a linear equation, and we sort of like gave this P football performance to the first one, right? And we gave this SMA2, which is simple moving average 2, to this other independent attribute. We said, we can perhaps capture this relationship by this linear equation. We didn't have to do that. We could have said, okay, maybe there is some nonlinear relationship here as well, right? So we could have said there is some nonlinear relationship. We include the linear terms, right? This is the first linear term, this is the second linear term, and this is the new nonlinear term, which is also the interaction between football performance and the simple moving average for 2 years. Or we could have just kept that, sort of like interaction to it by itself and sort of like make it a little bit more complex nonlinear function. I mean, we have previous football year performance power to the simple moving average by 2 years. Or we could have had, another one. We could have, create just, we didn't need to include the interaction. We could say, okay, previous football year performance power to 2. So it's just itself. There is no interaction, but it's not linear. And, the simple moving average is, sort of like 2.7 power to simple moving average. It's still not linear. And that's also a nonlinear regression. I mean, there is no guarantee that which one of these are going to have a better performance. That's the trick of nonlinear regression. Is you can have any equation as you want, but are those equation are going to be successful or not. And that's going to be very challenging to be able to come up with. I mean, if you have a really good mathematical understanding of these functions, you might be able to look at a visual. I mean, if it's only 2-dimensional, and say, okay, it looks like that function, and use that function, and that would perfectly fine. But once you actually have, more than 3-4 dimensions, even having those mathematical understanding by looking at these functions, that might not be sort of like serving you for you to be able to come up with these equations. So that's the Achilles heels of nonlinear regression. It's what function do we use? I mean, you can use whatever you want, and the betas will be estimated, but how do we know which functions to use is the challenge. But anyway, let's move on to fitting the data to a regression model. We did talk about this a little bit, but just let's talk about it one more time. So what we mean by regression model every time is that regression equation. I mean, if the regression equation is nonlinear, it's a nonlinear regression model. If the regression equation is linear, it's linear regression model. Basically, we estimate the beta, so the equation or the regression model can best fit to the data. By that we mean it can predict the target the best possible way. So for example, here, if you remember, this was our data from 2006 to 2021, and we wanted to connect the independent attributes to the dependent attributes, and we are using a regression model, and this is our regression model, right? So we fit this data to this model, and then we calculate the betas. Pay attention to the betas here. We calculate the betas, and these are the betas. If it was a nonlinear regression, I mean, there are methods to calculate those betas as well. I mean, at some point we will estimate these betas with some methods, and when we get these betas, all we need to do at that point is we have the next year football performance or the next data objects football performance, and then also the simple moving average from the last 2 years number of applications, and then we just plug and play. We put this for football performance, and then this put for this one, and then it will give us a result, and that will be our prediction that we are using we're using regression model, which was for this case was a linear regression model to estimate these. Like I said, this could have been a nonlinear model, and we would just estimate the betas like the way we are here, and we would be able to predict, but have to be able to sort of understand which model is doing better. Are these betas reliable? Is this model a good model? All of those things are questions that are very important, and in the one of the next videos we're going to learn how to do that. In the meantime, let me offer you a short summary of this video. In this video we talked about what is regression. We start from the word regress, and then we move our way to what is the statistical meaning of regression. Of course, we saw what is the difference between linear and nonlinear regression, and we saw an example to understand this better. Until the next video.